Topic 7.1 Summary, Part 2, Nuclear Structure. The nucleus of an atom is composed of protons and neutrons. A proton is the same thing as a hydrogen nucleus. It has a mass of 1.67262 times 10 to the negative 27 kilograms and a charge of positive 1.60 times 10 to the negative 19th coulombs. Of course, that's the same as the charge on an electron, except it's positive. A neutron, discovered by James Chadwick in 1932, has a mass of 1.67493 times 10 to the negative 27th kilograms, and it has no charge. Together, protons and neutrons are called nucleons. Some elements have several isotopes. Isotopes are nuclei that have the same number of protons but different numbers of neutrons. One thing interesting about isotopes is that they are chemically identical. This is because the chemical properties of an element are controlled by the electron configuration and not influenced by the number of neutrons. As a result, it's not possible to create a chemical reaction that will differentiate one isotope of an element from another. The only way to separate isotopes is by mass. Here's how we represent elements symbolically. We have a symbol for the element, and then above and to the left of the symbol for the element we have the atomic mass number. The atomic mass number is the sum of the number of protons and neutrons. To the bottom left of the symbol for the element we have the atomic number, which is the number of protons. The number of neutrons, cleverly called the neutron number, then is going to be the atomic mass number minus the number of protons. Here are three terms with which you should be familiar. The first term is nucleons, and nucleons is just a combined name for protons and neutrons together. Next we have nuclides. Nuclides are different types of nuclei. They're like elements, but they only are referring to the nucleus. And then finally isotopes, which we just talked about, are elements that have the same number of protons but different numbers of neutrons. Here are some examples of isotopes. These are all isotopes of carbon. We have carbon-12, which is the most common form, carbon-13, carbon-14, which is used for radioisotope dating, and carbon-16. So those are all different isotopes of carbon. Notice that the atomic number for all of the isotopes are the same because they all have 6 protons, but the mass number is different because they have varying numbers of neutrons. Another term to know is natural abundance. The natural abundance of an isotope is the percent of the atoms of a particular element found on Earth that consist of that particular isotope. Let's look at some examples. Okay, again, so here are 4 isotopes of the element carbon. Carbon-12 is the most common, and so if you were to, say, dig up a diamond, which is made of carbon, and analyze, if you would count the atoms in this particular chunk of diamond, you would find that about 98.9% of the carbon atoms are carbon-12, and about 1.07% are carbon-13, and carbon-14 is much, much, much rarer. In fact, you won't ever see it published as a percent, but about 1 atom of carbon out of a trillion atoms will be carbon-14. So again, the percentage of the element which is a particular isotope found naturally on Earth, that's called natural abundance. As you know, the nucleus of an atom is really tiny, and it's filled with protons. And those protons are all positively charged, and you know that like charges repel. So the positively charged protons in the nucleus are very close to each other, and that's going to result in strong repulsion between the protons. So there must be some other force that's holding the nucleus together. And the nucleus is bound together by a force that we call, cleverly, the strong nuclear force. The strong nuclear force is kind of interesting because it doesn't follow the inverse square law like many forces do. In fact, the strong nuclear force acts only at distances of on the order of 10 to the negative 15th meters or less. That's about the size of a nucleus. And that's all, folks. Oh, wait, I have a clever definition for you. Bernadette. Bernadette is the act of torching a mortgage.